Hi, everyone. Thanks for showing up for your learning. And welcome to this coffee and Halloween candy edition of Math with Me. So let's go through these different skills on the Delta Math assignment for Unit 1, and I'll do some example questions for you. You can follow my example solutions to lead you to a greater understanding of these topics to prepare yourselves for grade 12. When you've been asked to factor a trinomial, trinomials like to factor into two binomials. So here I can just, I'm just going to experiment here with copying this and pasting it into a whiteboard and seeing how that works as far as making a video goes. Oh, that's not what I want. Boop, boop. No, that doesn't work. Okay. This may be the shortest video. I may All right, let's try it this way. So here we have x squared plus 8x plus 15. So, of course, I can copy out this on a piece of scratch paper. So I would have x squared plus 8x plus 15. And then what I'm going to do with that to factor it is I want to find two numbers that multiply together that will give me 15. They have to multiply to that, and they have to add to this. So this is something I want them to add together to give me that, and to multiply together to give me that. So I can start by factoring 15. And I could say, well, I know one way to multiply to 15 is 1 times 15. But when I try and add those together, I get 16. I don't get 8. That doesn't work. So another way I know how to multiply to 15 is 5 times 3. And I know some other ways too. I know negative 5 times negative 3 will also multiply to 15. But only one of these adds to 8, and that's 5 and 3. So what that allows me to do is I found these secret numbers. They're the numbers that are connected to these x's by addition in the binomials. What am I doing? What I want here is these two numbers here, x plus 5 multiplied by x plus 3. Okay, that's how I factor those. Find the numbers that multiply to this and add to that. Notice that includes the signs. All right, so now let's take a look at some more questions here. So if I grab that and move it over, that should be fine. If I do one more problem, that's fine. So these ones multiply to 28 and add to 11. Well, 7 times 4 multiplies to 28 and adds to 11. So there you go. That's how you do them. You spot those numbers. Next, we have multi-step factoring that I've asked you to do. Now, these ones are fun questions because you need to do several steps to factor them fully. So if I have one like this, I'm just going to move this up here. Okay, there we go. So negative 5x squared plus 65x plus 150. And to factor one like this, now first we are going to look for common factors. That's always the first thing that we're going to do when we're factoring, is to find common factors that we'll remove. And that makes the whole problem simpler. And I see this number here, negative 5. It's a factor for 65 and 150. So let's bring our equal sign down, because the thing we're going to write here is equal to this. And then I'm going to factor this negative 5 out. And then I need to multiply that by x squared to recreate this negative 5x squared. If I divide 65 by negative 5, that will give me negative 13x. And then 150 divided by negative 5, well, that would give me negative how much? Negative 30. Okay. Now, just taking a look at what I have here, I always want to be able to check my work and make sure I haven't made a mistake here. Make sure that this equal sign is still true. So if I use the distributive property and I multiply this number back in to this whole bracket, that way I can check my work and see if this is all still true. Negative 5 times x squared is indeed negative 5x squared. Negative 5 times negative 13 is indeed plus 65, and then I have the x there, so that's right. And then negative 5 times negative 30 is 150. Positive, because negative times negative is a positive. So I know that that's all true. Am I done? No, hardly at all. I still need to factor this as a trinomial. And here I have two numbers that multiply together to give me something negative. So I know one is negative and one is positive. That's just the way you have to multiply two numbers to get a negative. So one's negative, one's positive. So I know my signs are going to be like this, x minus and x plus. There's going to be two numbers in here that multiply to 30 and that add to negative 13. All right. Wait, what? Yeah, strange, eh? So multiplies to negative 30 and adds to negative 13. I found them. Okay, so lots of different factors for 30. So at a time like this, you might do a little bit of scratch work on the side. And you might say, okay, 30. Well, that's 2 times 15, which is 3 times 5. And then you get the prime factors here, and then you can group them in different ways to create all the different ways to multiply to 30. So maybe I try 2 times 3 is 6, and I could try negative 6 times positive 5. That would give me negative 30. But together, they would add together to give me negative 1. So they're much too close together to produce a number as big as negative 13, or as negative as negative 13. But then I might say, well, let's take this 2 and multiply it by 15. That will give me two numbers that are pretty far apart, right? So then I might check, well, what about this like 2 multiplied by negative 15? And then I find that multiplies to 30 and it adds to negative 13. So those are my numbers there. So I'm going to go back to back in black here. And then we're going to say that we have negative 15, x minus 15 times x plus 3. Okay? And that will be the final answer. So this is negative 5 multiplied by x minus 15 multiplied by x plus 2. I say x plus 3? Well, I'm just going crazy over here. It's not x plus 3. It is 2. 2. So let's just, yeah, x plus 2. There. And those who multiply negative 30, I don't know, to negative 13. Okay, so let's just confirm that I am right. Yes. Hooray! And then you always want to look at their way of doing it. So they did the same thing as I did, greatest common factor, and the trinomial factor adds to negative 13, multiplies to negative 30. Boop, boop, they found them. Done. Okay, cool. So now let's take a look at some more skills. Factoring trinomials where a is greater than 1. These are more challenging. And I recommend quadratic formula because everyone needs more practice with quadratic formula. Hey, and don't draw all over it like that. There. Okay. So let's go. Quadratic formula. So 2x squared plus 7x minus 4. All right. Now, my a is equal to 2. My b is equal to 7. My c is equal to minus 4. Crank them into the quadratic formula. It will give you the roots. Watch. X equals negative b, so negative 7, plus or minus. The square root of b squared is 49. That's 7 squared. Minus 4 times, usually we do our brackets this way, Mr. Jennings, times 2 times a times c, which is negative 4. Okay? Negative 4 times 2 times negative 4. Okay. So negative times negative gives me a positive here. Oh, and this is all over 2a, so 2 times 2. Equal to negative 7 plus or minus the square root of 49 minus, okay, negative 4 times negative 4. You need positive 16. Positive 16 times 2, positive 32. 49 plus 32. 49 plus 32 is 81. This is the square root of 81. Okay, isn't that nice? Square root of 81. We have to simplify that, and we know how to do that. It's pretty straightforward. All over 4. Okay, so let's keep going. So now, there. Okay, so this is now equal to negative 7 plus or minus 9 over 4. Negative 7 plus 9. So this is either negative 7 plus 9, which would be 2 over 4. So this is either 1 over 2 or negative 7 minus 9, be not minus 16. It's either 1 over 2 or negative 4. Okay, so now these numbers are the roots of this quadratic. And we just didn't put them into the standard form. No, stop it. So what does that look like when we put it into the standard form? Well, Let's take a look. We had 2x squared plus 7x minus 4. Let's just zoom out a little bit, give ourselves a little more space over here, and I'm going to write it over there. So I know that 2x plus 7x minus 4 is going to be equal to 2. This stretch factor just comes over. It's 2 multiplied by x minus the first root, minus 1/2, multiplied by x, that's how I do it, x minus the second root, which would be x plus 4. Okay? Remember, these are sign flippers. In the factored form of the quadratic, the general factored form looks like this. It's equal to a x minus r multiplied by x minus s. Okay, r and s are the roots. I've just used these roots and then put them in here. Minus 1/2. See, this was positive, so I have to subtract 1/2 from x. That'll give me one of the roots. And minus 4 over there, like that. Okay, and then now I wonder if Delta Math would take that as an answer. I know that they will take this as an answer, 2x minus 1 multiplied by x plus 4. What'd you do, Mr. Jennings? Well, I would take this as a final answer. I think this is beautifully factored. But I think they want this. What I did was I just expanded this 2 in here to remove the fraction. Okay, that removes the fraction and it gives us a 2x minus 1 multiplied by x plus 4. So let's put that in. 2. I know that they're going to take that, so let's try 2 multiplied by x minus 1 over 2. Oops, I'm in French. I was just writing some French. 1, there's my slash, over 2, and bracket times x plus 4, bracket. Let's see if they take it. Yes, I'm sure I want to give you that answer. No, they don't like it. Okay, I didn't think so. Okay, so see, this is what they did. This is how they did it. All right, and then they said final answer, and I said this, which is equivalent, but it's not the form they wanted. Okay, so that's fine. All right, no problem. You want to do it their way. So I've tested for you. You have to multiply those factors in. Okay, now we're looking at standard to vertex form. Put the quadratic into vertex form and state the coordinates of the vertex. Okay, so now we have been asked to complete the square. Change this from standard form to vertex form. So let's go over and we'll do that. All right, let's get some fresh whiteboard up here. And this is minus 27. So, okay, let's write it out. First thing we do, write the question. Y is equal to x squared minus 6x minus 27. Okay, we're not asked to factor this. We're asked to put it in vertex form. So do that. Okay, how do we do that, Mr. Jennings? Well, first thing we do, we put a bracket around our x terms. X squared minus 6x. We can leave a bit of space here if we want to save a line. Minus 27. And then we're going to take this number and we're going to do some gymnastics to it. We're going to take minus 6, divide it by 2, and square the result. That gives us negative 3 squared, which will be 9. So I'm going to add 9 and subtract 9. The reason I did that is because what I've created here is a perfect square. Okay, it's a perfect square. And if you're watching the video, which I hope you did, of taking up the test and going over how to do those types of questions, you'll see that completing the square here, these squares. So this is now the same thing as saying x minus 3 squared. Where did minus 3 come from? It's right there. Negative 6 over 2 is minus 3. So that's how I know what belongs inside the square. Then I have minus 9 that I need to now bring out of the bracket and combine with this. Because I have an a of 1, this just comes out. It's like the brackets aren't there. Doesn't matter. Brackets. Makes no difference. So here, this would be minus 36. That will be done final answer, but I also need to say the coordinates of the vertex, which is, of course, 3, negative 36. Why 3, Mr. Jennings? Why not negative 3? Because this one's also a sign flipper. You have to remember that that's a sign flipper there. So let's put that in. This is equal to bracket x minus 3 bracket squared minus 36. Put in the vertex 3, negative 36, Mr. Jennings. Submit answer. Yes, I'm sure. Hooray! Okay, make sure you give yourself a pat on the back when you do that. Okay, So it's standard vertex form. Are there other question types? Will we get some A's? No, they all have an A of 1. So these are easier than the ones I asked you to do on the test. You do need to know how to do this when A is not 1. So watch the video of the test and I show you how to do those, the ones that we had on the test. Multiply and divide radical expressions. Okay. What is the product of 8 root 5 and 2 root 30 in simplest radical form? Well, let's get some more whiteboard here. Copy it out. The product. What's the product mean? Product is another way of saying multiply. Oops. Go away. There. Now you can see me. Like that's important. All right. So now here. 8. Oh, I did it again. Ugh. Hey. Hey. All right. It would just really bother me if it stays that way. Okay. 8 root 5 multiplied by 2 root 30. Two ways to go with this question. One is just go straight for my rules right away, which is I'm going to multiply coefficient times coefficient, and I'm going to multiply radical times radical. Just do that right away. The other option is to simplify this one first, and then I think they'll have a common base, and it'll be a little nicer. So, oh, right, I'm all black because I'm just going to do the work. Okay, here we go. All right. So 8 root 5 times 2 root 30. So I multiply coefficient times coefficient, 8 times 2. And then base times base, which will be 5 times 30. And now I got to simplify that. It's kind of ugly. This is equal to 16 times 5 times 30, which will be 150. It's not a perfect square. It's really darn close to 144. It's very close to 12, this number. Now I got to simplify it. 16 times, well, this is 25 times, what else do we have in there? 25 times 6? Yeah, it's 25 times 6. So 25 is a perfect square. 6 is not. 6 has no squares in it, so it stays inside there. And so the 6 is going to stay inside. Okay, so this will, and the 25 can come out. So this would be equal to 16 times 5 root 6. 16 times 5 is equal to 80 root 6. There, that's done. Final answer. 80 root 5. What did I do? Did I write that down right? I root 6. Oh, jeez. Jeez, I typed the wrong thing. I was thinking about something else, okay? All right, so now let's go over here. Let's do it the other way. This is the way I'd recommend doing it. Simplify first. 8 root 5 times 2 times, well, 30. Yeah, this doesn't really simplify. Sorry, it doesn't simplify. This is 6 times 5. And then I might notice that these 5s will simplify once I do the multiplication. But this was already simplified. I guess I'm not thinking as clearly as I think I'm thinking today. Okay, let's go ahead and we will get a new problem. It says multiplying and dividing. Now let's take a look at adding and subtracting these radical expressions and what we need to do when we're adding these. So this here, this just works like I have negative 10x plus 2 times x. This root 10 works the same way as like a variable would. So this, I just combine them and I say this is minus 8 root 10. Okay, I just need to be able to do that. Submit answer. Yes. Okay, that's correct. And we already have like terms. Yay! But they're not always going to give you like terms. Let's look at some more. That's a like term. Maybe I should ask you to do more of these. There we go. That's a good one. Let's do this. Oh, my children are here. Give me a second. Hello, children. Okay, we're going to carry on. So let's take a look at this problem here. So let's get some space. I'm just going to save so much paper having this little tool. Negative root 180 plus 4 root 5. Okay, so to simplify it first, I'm not going to worry about that anymore. It's just driving me nuts. 180 plus 4 root 5. Okay, now I want to simplify this first. So 180. Zara, get your hand out of my face. Bye. Bye-bye, honey. Bye-bye. Okay, you can say hi, but they're here to get math help. They're not here to watch you be amazingly cute. 180. Let's talk about this 180. It's got a 9 in it. And it's a perfect square. So when I do that and I divide it out, it leaves me 20. Now the 20 has a 4 in it. Okay, so I see some perfect squares in there. So I know that I can write this as 9 times 4 times 20. Okay, and then this is plus 4 times root 5. Oh, interesting. Okay, cool. Oh, wait, 9 times 4 times, not 20, 9 times 4 times 5. My goodness. Okay, so let's take that out. Go back here. 9 times 4 times 5 gives me 180. All right. So this is now negative the 9 and the 4. Each pop their square root out. So that's 3 times 2 minus 6 root 5 plus 4 root 5. It gives me negative 2 root 5. How'd you do negative 2 root 5, Mr. Jennings? Like this. Watch. This is equal to negative 6 plus 4 times root 5. I just factored out the root 5, okay? It's a common factor. Take it out. And then do this. Negative 2 times root 5. There it is. It's just like adding x's together. If I have 3x plus 4x, this equals 7x. Okay, so do it that way. All right. Now, let's find some other question types. Solving quadratic linear systems. Yay! Just what everyone wanted to do. Solve quadratic and linear systems. Because it's super fun to solve quadratic linear systems. I'll show you why. Here. The reason is because not everyone can do it. And if you can, you're definitely above average math person in this society. I bet I'm the only person in the house right now who can do this. Mind you, 2 of them are in kindergarten. 2 of the other people. Y is equal to negative x minus 4. Okay, so to make these, to find out where these things touch. So here, this is a parabola. This one opens upwards, and it looks something like this, okay? This parabola. And then this is a line, negative x minus 4. This is a line that looks like this. Okay, I'm actually a little surprised that these touch. They must touch maybe like over here or something. It must be a lot deeper than I think it is. Anyway, let's find out where these touch. Did I write them down right? Yes, I did. Okay, so how do we do that? Well, this is how we do it. We say at the point of intersection, the y is equal to the y. So I'm going to write negative x minus 4 is equal to x squared minus 11x plus 17. One equation, one unknown. I can solve that. So let's do our inverse operations. We're going to bring everything to one side by adding x and adding 4 to both sides. And then that will be equal to, go away, menus, x squared. We didn't do anything to that, x squared, plus 10x. Why did I say plus? Minus. There, minus 10x. If I drew another plus there, you'd be like, oh, you're crazy, Mr. Plus 21. Okay, I'm looking for numbers that add to positive, multiply to positive 21 and add to negative 10. Negative 3, negative 7. Okay, that does it. Okay, so then we factor this as a trinomial. X minus 3 multiplied by x minus 7. Oh, what is this all equal to? 0. This is equal to 0. Why is it equal to 0? Look, we did the inverse operation, so we had zeros over there. Okay. All right, so let's, now we solve this. Therefore, if you want, you could write x minus 3 equals 0 or x minus 7 equals 0. Okay, so then x equals 3 or x equals 7. I got that by adding 3 to both sides. Okay, now I know half of each solution. These touch in 2 places. Okay, they touch over here at x is 3 and x is 7. I guess this parabola does go really deep down there. I'm expecting some negative values for this parabola. So let's find out our y values, and we'll get that by substituting into one of these 2 equations. Okay, so zoom out. and then we'll work over here. And then I'm just going to solve for my y values in blue. Okay, so y is equal to negative 3 minus 4. This is when x equals 3. Then y equals this. Y equals negative 7, just like I was saying, it's very negative. Or if x equals 7, y equals negative 7 minus 4. How do I know? I'm just substituting into this equation here. And I substitute in there for x, and I substitute in down here for x. And then I find that y is equal to negative 11 when x is 7. So now I can write my two solutions as 2 points because I'm looking for points of intersection. There's 2 of them. Write them as points. So first one is 3. The next one is negative 7. The next one is 7 and negative 11. That's kind of cool. You can remember 7, 11, and you'll always remember the intersection between the quadratic x squared minus 11x plus 17 and the line y equals negative x minus 4. No, that's not like a handy thing to remember, but it's the method that you want to know how to intersect these. Okay, so they have 2 solutions. The answer, and you'll have other options: no solutions, 1 solution, or 2 solutions. Okay, all 3 are possible. Line can touch once, twice, or nonce, not at all. 3 negative 7 or 7 negative 11. Okay, so let's type those in. 3 negative 7 or 7 negative 11. I'm just testing to see if I can submit that without brackets. Yes. No, doesn't like it. Okay. Yeah, don't like it. So you have to put in brackets 3 negative 7 and 7 negative 11. Okay. You must write your answer as coordinates with parentheses. Okay, yeah, so you have to write the brackets, okay, when you put it around your points. Okay, see, they found the x's, they put them there, and then they find the y values, and they plunk, put them in there. Make sure the right y value goes to the right x value, and you're golden. Okay, now keep going. Solve quadratic linear systems, level 3. Okay, yes, I gave you more challenging examples to solve and try. These are the hardest questions on this recap test. So let's get ourselves some good whiteboard space here. Good whiteboard space. We're going to work in black because we're back in black here. All right, let's go. So I have y is equal to 8x squared plus 52x minus 5. And then there's also, I'll just write over here, y is equal to negative 3x plus 2. Okay, set them equal to each other. Negative 3x plus 2 is equal to 8x squared plus 52x minus 5. Add. Add 3x to both sides and subtract 2 from both sides. Add 3x and subtract 2. Okay, that's going to give you a 0 on one side. Once you've got a 0 on one side, you can find much more easily the values of x that make the equation 0. That's why we do this. That's why we move everything to one side. 0 is equal to 8x squared plus 55x minus 7. Does this factor? I don't know. Probably. But you know what? I don't care. I don't want to go looking around for that. Looks like if I multiply 8 and 7, and it's positive, that will give me 56, and then subtract 1. Yeah, I can do it. Okay, I can do it. All right, it's going to be this. It's going to be 8x minus 1 multiplied by x plus 7. Okay, I noticed that there's only one way to multiply to negative 7. It's negative 1 and 7. Sorry, there's 2. There's negative 7 and 1. There's a few ways to break up this 8, but I saw that this is a very big number, so I would need to multiply the 8 by the 7, give me 56, and then multiply this x by the negative 1 to take it down a notch and get there. Let's say you can't spot that, okay, because I don't expect you to be able to spot that. I expect you to use quadratic formula here. A equals 8, B equals 55, and C equals negative 7. Okay? So now we crank it into the quadratic formula. X equals Negative 55. Don't get tired, Mr. Jennings. You're almost at the finish line. Plus or minus the square root of 55 squared. Minus 4 times 8 times negative 7. All over 2 times 8. So that's just substituting into the quadratic formula. Now let's evaluate. 55 squared? My goodness, you want me to do that? I suppose I could. You want to? You don't want to? You could do that on a calculator, or you could do it longhand, right? And that's 25. 5 times 5 would carry the 2. 5 times 5 is 25, so this is 275 over the same thing, 2,750. And then you do this with 5, and this is 2, carry the 1, and then that's 3 is 0, and that's 3025. Okay. Equals negative 55 plus or minus square root of 3025 minus 4 times 8 times negative 7 minus 4 times 8. Wait, this is going to be plus because it's minus times a minus. So 4 times 8 is 32. 32 times 7 is, my mental fatigue is high when I need to do 32 times 7 longhand here. This is 22. Yeah, 224. Plus 224. Okay, all divided by 16. Okay, this is equal to negative 55 plus or minus the square root of 3025 plus 224. 3249. That's going to be something squared with a 7 on the end. 27? No. 17? No. No, 27. 200? No. What is it? 40? So? Yeah. I don't know. I will have to check with my handy dandy. Do it on the calculator, Mr. Jennings. Calculator. What was that number? You guys are also like, Mr. Jennings. Rest. Don't do this to yourself. 3249. Take the square root of that number, please. 57. There we go. Okay. So this is equal to negative 55 plus or minus 57 all over 16. Actually, based on the roots that I already knew it had over here, I could have just told you that. So if we have plus, then we would be equal to 2 over 16 or 1 over 8. Or we have another solution, which is minus, negative 55 minus 57, which would give us a negative 112. Or it's equal to negative 112 over 16. 112 over 16 is negative 7. Hooray! So there's the two values of x, 1/8 or negative 7. So we have this as a solution with some value y, and this is a solution with some value y. Now we have to find those numbers. Where are we going to find those? We're going to find them from the line for sure. You could substitute into the quadratic if you want more practice. So if you want less practice, substitute it in here. If x is 1/8, this would be negative 3/8 plus 2. Negative 3/8 plus 2 will be the same thing as 2 minus 3/8. When 2 is 13/8. Someone likes Fibonacci numbers who created this. This is beautiful. 13/8. There's so many Fibonacci. 13 is Fibonacci. 55 is Fibonacci. It's pretty. Okay, 13/8. And then negative 7. Let's check negative 7 here. Negative 3 times negative 7 is positive 21. Another Fibonacci. Isn't that beautiful? Plus 2, 23. Okay, so here are the two intercepts, 23. Let's go ahead and submit that. We have, okay, so bring this over here, Mr. Jennings, so we can see. We have two solutions. The first one happens at 1 over 8. Oops, what am I doing? 1 over, no, this is how you do over 8. And show them, Mr. Show the people want to see. Okay, comma. And then we said that was 13 over 8 for y. And bracket. And the other one was -7. And that one was at 23. Input your things as points like that. Submit answer. Yes. Yeah, I didn't make any mistakes. I also had done the question twice by factoring and by quadratic formula, so it backed up what I was seeing. This 1/8 shows up here. 8 times 1/8 is 1. 1 minus 1 is 0. That's why this creates a 0. Okay, so that's why quadratic formula or factoring are both valid ways to solve these types of problems. And quadratic formula is just do it. Okay, this to me is always like, can I spot it or can I not? And then if I can't spot it, I'm a little bit in trouble. Okay, so that's it. That's how you do this these club questions. All right, Unit 1 Club. So I hope that's all helpful for you. I hope that you were able to go through the video and find the part that you need, and that I didn't unduly bore you with the part that you don't. Okay, and I hope your math practice is fruitful. Definitely contact me with any questions. Bye.